Everyone, today we are going to talk about minimum window substring. I mostly make these videos because it helps me better understand the topics and catches any gaps that I may have missed out on when I was reading the information on some subject. It helps me conclude that I have actually understood something or I thought I understood something. So yeah, without further ado, let's get started and let's understand the problem. Also, if anyone is here just to see the code, you can directly go to that section using chapters. All right. The problem in simple terms looks like this. We are given a string S and we must find a substring such that the second string, which is T in our case, tends to become a subsequence of that substring. If you find multiple substrings, return the one with the minimum length. And if no such substring exists, we simply return an empty string. So for anyone who doesn't know the difference between a substring and a subsequence, I will try to explain that to the best of my abilities. For anyone who does know, this will be a quick recap. So what is a substring? A substring of string G is any string formed by taking one contiguous run of characters out of G. For example, there is a string S and there is a string T. So nerve will be a substring of interview nerve if we find nerve in the string. In that case, we do. So we can say that nerve is a substring of interview nerve. Okay, so now you ask me what is a subsequence. So I would define subsequence as, let's go in quotes and see what it means. A string Q is a subsequence of string G if you can delete 0 or more characters from G, which is anywhere, and end up with exactly Q, with the remaining characters still in their original order. So two things that matter here are, first is the order, and second is they need not be contiguous or immediate. Could be, but they need not. So if you look at this example where I extended S with one of us, that is more characters, and then change T to nervous. So here we have to pick each character in S to make sure we find that character matching with the character in T. Okay, let's start picking. So we move on to the next one. We now find E as well, V, O, U, and S. You can see we found all the letters and they are found in order, meaning we are not considering the N that comes after E, but the one that comes before E. So these contiguous string of characters will become the substring for which T could be a subsequence. So nervous is a subsequence of S, but not a substring. In this example, there are many substrings that nervous could be a subsequence to. It can be a fun exercise for you to finish. We will already be seeing the one with nerve. So is nerve a subsequence of S? Why, yes, it is. It is a subsequence of S. Being not contiguous is a leniency and not a requirement. So nerve most certainly is a subsequence. To conclude, a substring is always a subsequence of a given string, but a subsequence may or may not be a substring of a given string. After all this jibber jabber about substrings and subsequences, let's try to look at the problem. We have to find a substring such that T is a subsequence of that substring. We have a couple of options here. Nerve is the subsequence to the substring if we just exclude the I here, sequence to this substring, and this one, and this, and a whole bunch of others. So you get the point. We have to choose the one that has the minimum length. In our case, it is nerve. Let's look at the code to understand this better. We start with simple things. We define a function which takes the parameters as two strings. We define them as S and T, and we store their lengths in M and N for convenience. We then check if the length of T is greater than the length of S. There is no point to check anything further, and we can just return an empty string. Now, I need a couple of things here. Firstly, I want to track positions of my characters in S and T. Two pointers to do that. We'll use I to track S and J for tracking the characters in T. I need a string and I can initialize that to an empty string. To track the position of the start of the substring and the end of the substring, we use two more pointers to get it right. Here we have the start and the end pointers. We are done with the initialization of variables that we might need later in the code. If we want something else later, we will add those variables later. Right now, this is all I could think of. The initial condition for our loop is to check bounds. The bounds are that our pointers don't exceed the length of their respective strings. In the outermost loop, we will be incrementing I in the end. Now, we have to think of when would j be incremented, and for that, we have to check this condition. And the condition is if s of I is equal to t of j. If this condition is matched, we will increment j at the end of this condition. This tells us that we found the character from t which is also present in s. Okay, now that we have the forward mechanism for the loop, let's see what else we need to check to get this working. We need to figure out the start and the end pointers of the substring. We have to find the end first. Can you believe it? If you don't, let's understand why that is. The first n we encounter is at the very beginning, but it did not matter because we came across a bunch of other n's later. To figure out if T is a subsequence or not, all the letters must be present in order and we have to choose the one with the smallest letter. So we need to find that E, which will mark the end of T. If E is not present after that V, we might as well return an empty string because we did not find all the characters. So the point here is we have to find the end first. Backtrack from there to find the nearest start. In our case, it's M, and we have to choose the one that is nearest to the found E, which in our case will lead to nerve. When do we know we reached the end? We find all the letters in T, and then we know we have reached the end. So J should be equal to M minus 1 in this case. So here we have encountered an end, one of the ends. As we have seen during the start, there are many substrings for which T is a subsequence. Even in interview, there is a nerve. So this end will be the first end, which is the E right before W. So that will be the first time we encounter an end. So the end here will become the ith value. And now we have to find the start. Backtrack with start's initial value being the same as the end. Like the loop we have running outside, we start the same kind of loop inside, but with reverse logic. So the condition we first check is while start is greater than or equal to 0 and j is greater than or equal to 0. And now we need to check some condition. This condition is similar to the outer loop, but what it does is find the characters which are closer to the end and make sure that we are choosing the most optimal length for this, which is the shortest length. Here we check for the characters that are equal, and at the end of the loop, we decrement the pointers. Here j is decremented when the characters match. This is the same as the outer condition, where j is incremented when the characters match. The start is decremented every cycle. Everything is the same as the outer loop, but in reverse. We just decrement and try to find the nearest start. Once we find the start pointer will be decrement one extra time, and to find the exact start, we need to have the one that was the very next one, which was the previous value. We will do start plus 1. And as we know the string doesn't consider the end value for range, we will have to plus 1 that too. So end will be end plus 1. Once we find the start and the end, we store our substring, which is a simple logic. If it's an empty string, store the first substring that we encounter with the start and end pointers. And if we already have encountered a substring before, we store the one with the least length. And now we have to reset the value of j. We would change this to -1 because once the condition ends, j will be incremented again, and it will become 0. This ensures that we start with the first character in T, and then we have to think about I, which will be same as our start value. And that will also be incremented by 1. We begin with the very next one after our start. This is all that we would have done ideally, but we won't because first, we have already encountered the shortest substring so far. There is no point in checking the characters till the end pointer. We do not need to modify the value of I. I will be the very next character to our current end. And j should also not be equal to -1 because we already know there is one start that is present. So we are never going to encounter a condition where a start might not be there. We just need to keep checking the other characters to find the end again and then backtrack to find the start. Because we always backtrack to find the start again, we don't need to check start here if it's present or not. Instead of j is equal to -1, we will make j is equal to 0. And while iterating further, it will be converted to j is equal to 1. And that's it. We return the substring with the smallest length. Here's the entire code. Let's look at a few test cases to understand how our code is doing. The first one is our simple example, interview nerve, and T is nerve. The output will be nerve, same as what we saw in our example. The second test case is also similar. This one is peculiar because of the presence of so many ends. If we had not backtracked the start position, we would not have been able to find the substring with the minimum length. The third test case is if we remove nerve from our string and just have interview, we would get N, T, E, R, V, I, E. For the fourth test case, I considered a few edge cases where the value might be small and my logic might have fumbled, but in our case, it did not. Glad it worked out. If t is just I, which is length 1, we get the same thing, which is I. If s has length 1 and t is a totally different character than s, we get an empty string. If both the inputs are empty string, we again get an empty string. If the length of s is smaller than the length of t, we also get an empty string. I have not tested it for larger inputs, and if you have a few that may have like billions of parameters and want to stress test, I would love to hear your thoughts and any improvements that you might want to suggest. This problem could also be solved using the sliding window approach and dynamic programming, but that is for another day. Coming to the important stuff, metrics. What is our space complexity? Space-wise, it looks like we are doing good. We only have constant variables that we keep for changing the loop. No major storage for storing string values or anything like that. We just store the minimum one. So storage looks constant and doesn't depend mostly on the size of the string. So yeah, the space complexity is O of 1. If we have a smaller substring that we need to find, the answer will even be smaller. But yeah, if the length of t is very large, like almost similar to like the length of s, then we might have like large storage values. But assuming that it doesn't, we are not that dependent on like the strings value. I would still lean over that this tends to be constant and not depending on the size of any given string. The space complexity is O of 1. Let's look at the time complexity now. We have one outer loop that is running, and it's mostly dependent on the length of the larger string. It could depend on the length of the smaller string, but n will always be larger than t when we are checking this condition. So we can say that the loop will at least be O of n. There is another loop for the condition when we reach t's end, and that one also could be potentially O of n if the start of the t is at the very beginning of S and the end is at the very end of S. But we will have to do it only when the end is reached. So in this condition, it would be O of 2n, which again will result to O of n. This could also be converted to O of Cn, where C is the number of distinct times the subsequence T occurs in S. C substrings, and if we consider C to be a constant, the value will still be O of n. So here the time complexity will be O of n. We are done. Yeah, I hope this was fun for you. It was fun for me to understand and to explain. Before we part, I have a question for you. For all the substrings that we had seen a while ago, like when we were understanding the problem, remember? If you don't, I will just show that to you again. All right, did that jog your memory? I hope it did. My question is, how would you modify this code to get all of those substrings in our output? We had found a bunch of them. There were so many, but we chose only the minimum length for this problem. But suppose if we are not doing that, how do you find all of them? It does sound fun, doesn't it? All right. If you think of an answer, you can leave a comment, and maybe you can also check my solution on GitHub and point out any flaws in my logic or bugs or anything. If I got my time complexity wrong or space complexity wrong, please reach out to me. So yeah, thank you so much for watching. If you found this useful, please consider subscribing and liking and sharing the video, and I will see you next time. Bye.